Welcome back to the whiteboard for another explainer. Look, for a long time, the entire enterprise AI conversation has been, well, totally obsessed with the model. You know the drill. Which model is smarter, which has the biggest context window, who writes code the fastest. But if you actually talk to operators trying to deploy these things, the model isn't the bottleneck anymore. The real bottleneck is getting AI workflows to run reliably, to restart safely after a crash, and, crucially, to include human approvals without holding the whole thing together with digital duct tape.
It's a phenomenon we see all the time, right? An AI agent looks absolutely magical in a controlled demo, but the second it hits the real world, it just dies. So why do these demos crash and burn before reaching production? Well, our resident skeptical analyst is already asking what we're all thinking. Is this just another buzzword platform jumping on the AI hype train? Or does Mistral Workflows actually solve the real pilot to production failure mode engineers are struggling with? It's a spot-on question. We really need to cut through the hype and look at the actual mechanics of durable automation.
Okay, let's look at the agenda for our whiteboard session today. 1. The real bottleneck. 2. Agent versus workflow. 3. Event replay. 4. The approval gate. 5. Production limits. And 6. An example lab. Let's dive right in and see exactly how to bridge that gap from a fragile pilot to a durable production system.
Section 1. The real bottleneck, pilot to production.
See, enterprise AI isn't failing because the underlying LLM can't draft an email. It fails because real business-critical workflows absolutely demand restarts, retries, and comprehensive audits. A simple API call just isn't going to cut it when money or reputation is on the line. Getting from pilot to production requires a fundamental mindset shift. You don't just need a smarter chatbot, you need a durable process. And what Mistral Workflows does, which is heavily emphasized in their official docs, is treat the workflow itself as the product. It's an orchestration layer built specifically for the unglamorous part of agentic AI, making multi-step processes safe enough to actually navigate that treacherous path to production.
Moving to Section 2. Agent versus workflow, the mental model.
We really need to separate these two terms, because confusing an agent with a workflow is a massive cause of bad system design. Notice the clear division of labor we have here. Think of the agent as the decision-making brain. It evaluates a prompt, decides on an action, generates text, all that good stuff. But the workflow? That's the choreography layer. According to Mistral's docs, the workflow handles the overarching sequence, the necessary wait times, and the retry logic. You can swap out your models or your prompts all day long, but without that workflow orchestration layer, you're literally just shipping a fragile chain of API calls that's going to shatter the moment a server hiccups.
Section 3. Event replay, determinism, and durability.
So, how exactly does orchestration keep things from shattering? Well, to understand Mistral workflows, you really have to understand determinism. If a workflow isn't deterministic, meaning it doesn't do the exact same thing in the exact same order every single time, it will break upon a system restart. This timeline brilliantly illustrates the mechanism. When a workflow is running, Mistral records significant events. Let's say step 1 finishes successfully. The platform logs it. Step 2 finishes, logged. Then, out of nowhere, bam, a server restarts. In a fragile system, you lose everything, back to square one. But here, the platform simply replays the recorded events to instantly reconstruct the state of the workflow right up to the exact millisecond before the failure. Then, it just seamlessly resumes. It's like magic, but it's just good engineering. But there's a catch with event replay. You cannot have your workflow making random calls to live databases or external APIs, because those answers change, which completely ruins the determinism. That's exactly why Mistral defines a concept called activities. Activities are where you absolutely must offload all your messy external I/O operations, your API calls, your database reads, the whole shebang. The main workflow coordinates purely deterministically, while the activities handle those unpredictable real-world interactions. All right, Section 4, the approval gate, native human in the loop. This brings us to what is probably the most important operator lesson in this entire explainer. How do you safely inject a human in the loop into an automated process without burning through expensive compute while the system just sits there twiddling its thumbs waiting for someone to click a button? Well, the Mistral docs outline exactly how this is done natively. They use what's called a wait condition primitive. When the AI reaches a critical step, say sending a proposal to a client, the workflow literally pauses. It doesn't consume heavy compute, it just waits for an external callback signal. Once a human manager clicks approve, that signal flips a Boolean value in the system, and the workflow instantly resumes. And you can easily program timeouts too, so if no one approves it within a day, it just safely aborts or escalates. Honestly, this changes everything about enterprise compliance. Our skeptical analyst brings up a great point again here.
The real governance win is that as an operator, you can mathematically prove to your compliance and legal teams that nothing executes until that cryptographic approval signal arrives. Precisely. Hit the nail on the head. It turns human approval into a first-class, foundational step of the system, rather than some clunky UI feature just bolted on at the very end.
Section 5. Production limits. Strict constraints.
So the crucial point here is that while this orchestration is incredibly powerful, it's not magic. It's infrastructure. And like all real infrastructure, operators must respect strict constraints to keep things stable. Let's look at the hard numbers directly from the Mistral documentation. First up, the number 2. Your workflow code must complete its coordination tasks within a strict 2-second timeout between activities. The workflow layer is for rapid coordination, not heavy lifting. If your code hangs for more than 2 seconds trying to figure out what to do next, the system is going to flag it.
Next, we have another number 2. There is a hard 2 megabyte limit for input and output payloads per invocation. You cannot pass massive video files or gigabytes of raw training data back and forth directly through the workflow coordination state. You have to keep your payloads lean, passing references to the data rather than the raw data itself. Finally, 51,200. This is the execution history cap for events, which roughly translates to a 50 megabyte history limit per workflow execution. What this means for you as an operator is that you absolutely must keep your workflow logic lean and efficient. If you design a workflow that loops infinitely or generates tens of thousands of tiny micro events, you will hit this cap and the workflow will terminate. You got to treat this like real engineering, not just a messy notebook demo.
Okay, final section. Section 6, Example Lab, Approval by Default. Now that we understand the rules and the underlying mechanics, let's actually put it together on the whiteboard. We're going to walk through a practical, completely copyable template for governed automation that you can take back to your team right now. Let's apply this to a highly risky automation, sending out a custom financial quote to a client. Step 1. The AI agent drafts the quote and computes a risk score. That's an activity. Step 2. The workflow pauses using that wait condition primitive we talked about. It asks for human approval and sets a 24-hour timeout. Step 3. If the human manager signals approval, the workflow resumes and sends the quote. If 24 hours passed with 0 signal, the workflow just expires the draft and alerts a human. This elegantly simple 3-step pattern completely mitigates the risk of an AI hallucinating a terrible price and automatically emailing it to your biggest client. By adopting this governed automation template, you are actively shifting away from that dangerous autopilot by default mentality. And if you're looking for an educational, structural example of how someone might actually package a governed workflow like this into a tangible dashboard interface, Howard's Side Hustle Command Center is a really interesting reference point. To be completely clear, we are mentioning it purely to illustrate how you structure these components visually. There's no hype or guaranteed outcomes here, just a really solid example of organizing workflow logic cleanly.
And that brings us to the end of our whiteboard session. We've seen that the models will inevitably keep getting smarter, faster, and cheaper. But the actual enterprise moat, the thing that truly separates toy demos from highly reliable, audited business systems, might just be orchestration and governance. So I'll leave you with a final question to chew on. As you look at the future of your own tech stack, do you think the winning enterprise AI strategy will be model first or orchestration first? Thanks for joining me on this explainer, and I'll catch you in the next one.